Thank you. All right, so I'm nowhere near as polished as Jason was, so my apologies. I really wanted to talk about continuous deployment and continuous integration and all the fun stuff that nobody really wants to talk about while writing application code. And I want to talk about that with like the context of Node.js. With that, I was like, oh, let me be cooler than this and get more people out, put more butts in seats by saying I use Jest as well. But the main point of this is kind of to go over a really, really quick way of putting together a Node app, writing tests for it, running through those tests, deploying that, and getting it up onto a Heroku environment, and then talking about why continuous deployment, continuous integration are very important, and why they're kind of like the future of how development practices go. So before we do that, let's talk about me for a quick second. That's me from 2 weeks ago. So if anybody takes a good picture of me today, I need a new Facebook picture. That one, I like it, but like I look a little bit tired there. Actually, what it was a couple of people who are currently in the back of the room were like, "Oh, we're gonna heckle you tonight," and so I was a bit anxious about that. No heckling tonight, Mr. Tyler. It's Tyler Sloan, everybody. So I am a startup guy. I've been in startups for my entire career. I've designed stuff. I've written code. I've been a product manager. I've done some marketing when I had to wear multiple hats. And I mean, in my last 2 years, I've been at 2 different startups. One that I started and failed epically at, and now another one, which is a payment system. And this time I'm letting other people actually drive the ship, and I'm just dealing with the engineering aspects. In my career, I've been heavily skewed towards JavaScript, but my real passion, my real love is actually making high-functioning teams and building high-functioning processes that we can actually ship really strong, really robust code. On top of that, I've been in very, very lean operations, which meant that we didn't have the luxury of having QA teams. We didn't have the luxury of having a lot of time between releases. It was always, let's move really quickly and let's break stuff, but let's break stuff in a way that we can fix it as quickly as possible, detect it as quickly as possible, and ship more code. Because like ultimately, the end user is affected by the code that you ship. People get new features, people get new awesome value from your product when new features are actually out and you're not sitting on it in development mode. But beyond that, if you can't fix a bug really quickly, you're gonna lose a customer. And I think that the most important thing that we should be doing as developers is writing code such that people are actually using the outcome of that. We wanna build high-performance systems and high-performance libraries that people actually use. We wanna build massive systems and scale those in a way that companies can do much better, get new customers, make more money, pay us bigger bonuses, and actually ultimately help us hire a better team. Also, there's my Twitter if you want to follow me. I often tweet random things at random times, often to my friend Brian back there. So, as I said, I want to run through a whole bunch of different things. The good news is I'm not going to sit here and code much. I've written all the code. I've done most of the pre-planning. There might be a little bit of stuff I need to do. But the main thing I want to do is write a really quick Node.js application. It's not going to be an API. It's going to be something that's testable. I want to write tests for it using Jest as a test runner. I want to actually push that code up to GitHub. You can use whatever other tools you want. And then jump into CircleCI as my continuous integration test runner. No particular reason for using Circle other than I use Circle all the time for other things. Currently reevaluating my CI tools, so maybe in a couple of weeks I can be like, oh, I'm moving over to something else. But for now, it doesn't matter. Heroku gives us the easiest and fastest way to push code up. So I'm going to use Heroku, and I'm going to try to tie them all together such that when I write some new code, this is the code I haven't written yet, and add a test to it, I can push that stuff up and let my CircleCI and GitHub and Heroku work together, and we can have more code back up in production. So the entire point of this is to say we can actually do this stuff really quickly. And from a development standpoint, it's not altogether that difficult, but it does require a little bit of rigor. And that rigor comes in with team discipline. It comes in with a whole bunch of other interesting things I'm going to talk about in a second. So who here knows what continuous deployment is or has worked in an environment that has that? All right, that's actually more than I expected. Who here, you don't have to keep your hand up if you've worked in an environment that has continuous delivery. How about continuous integration? How about agile? All right, so all these different things work together. I mean, agile is constructed in a manifesto by a bunch of very smart people back in the mid-90s, I think. I should check that out. But the entire point of agile was to move away from waterfall-style development, which was like, hey, let's just, and pretend I'm a manager right now. It's like, oh, hey, let's just make all those coders back there, all those nerds, try to fit in 8,000 hours of work into, like a 10-hour week, 10-hour day. That wasn't a very tenable system. So people said, hey, let's have a system that's a lot better. That's about pushing code out and actually improving on that code. Like, I guess the core part of Agile that I really like is the continuous improvement aspects of it. We're going to learn by putting stuff out in the wild. We're going to gather user feedback and improve upon that. Naturally, nothing great written by developers is going to last very long when it's in the hands of managers. So now we have like Scrum, which is, again, like mini waterfalls and other horrendous things. My apologies to those of you who work in agile shops where you're just still living the waterfall lifestyle. But what I'm trying to say here is that like there's actually a way out, and there are companies who don't actually worry about that sort of stuff. And I think actually the biggest example we can see of continuous deployment, continuous integration stuff is even in open source projects, because we see open source projects that are heavily tested. I mean, like recently React was putting out a new Fiber, which is a new reconciliation algorithm, and they have this big site, is Fiber ready yet? And it's showing all the different tests that need to pass before they're going to deem Fiber ready to go. And so we've been able to follow along all these different tests. And I'm a contributor to React in a very awesome small way. If anybody actually gets that joke, don't worry about it. But I get to see like the CI tests running, and it's really cool because these CI tests are running all the time. But that being a library doesn't exactly allow the Facebook team or the React team to start pushing that code up every time a test passes. But we as application developers totally can. So continuous deployment is about letting the systems actually automate deployment processes. Continuous delivery is a step away from that, in that we can deploy code as much as possible, but it's still a manual process. But continuous integration is saying we as developers who are working on a team, when we merge our code together, it's not going to be this gigantic process of, okay, guys, let's figure out our merge commits and let's sit next to each other and unwind every single merge conflict. Like, who's worked in that environment before? Oh, that's a fun environment to be in if you haven't been there. That is when you're sitting there and your engineering manager is sitting there cursing everybody on the team for that tiny little bit of code that they added in that had the wrong white space, and somebody's using spaces and not tabs, and this is like the world before Prettier, like 2 years ago. That's JavaScript world. But we moved on past that. We no longer need that. We have GitHub to at least help us, or Bitbucket, or GitLab, or whatever, to help us actually figure out merge conflicts before they actually happen. We have CI tools to actually help us run all of our different tests whenever anybody pushes up code. These things are really valuable to us because it means that there's far less yelling by the engineering manager, and you get out of there before 6 o'clock hits. You can hit the bar, happy hour. Ultimately, though, this is about it's about the development team building better practices for themselves and holding themselves accountable to each other. If we're going to ask for responsibility as developers, we better come through, and then management can come in there and say, "Oh shit, let's add more processes because we don't trust the nerds in the room over there. That they're back at it again. Their merge conflicts." But it's an awesome thing when you get to continuous deployment. So next slide. Prerequisites. Number 1, agreeable management. This is unfortunately also the biggest wall to hurdle. if you're working in an environment and you don't have management who are on the page or who don't see the value in building out more automation in these systems, I wager that's not the greatest environment to work at long term. There's so much business value, so much strategic value to having proper test coverage, to being able to automate your code, that if you don't have management that's agreeable, it means that, hey, your manager can actually make a business case, which is a big skill that a manager should have. But the other side could just be like people just don't give a shit, which is a scary situation. The team itself needs to heavily value testing. And I don't just mean like, hey, let's write a whole bunch of snapshot tests in Jest, or let's write a whole bunch of unit tests. It's like, we have to understand how to automate and do everything end to end. We have to have proper unit testing, proper integration testing, and it also doesn't mean, hey, we're gonna hire 3 QA analysts to sit there and run through the exact same regression tests every single day. I worked in an environment like that. We caught like 3 bugs and we missed like the big iceberg. I have a story about an 18-hour deployment. I'm not going to tell it right now, but you can talk to me later. You also need capability to automate things. These aren't just code-level systems that are in place. These are things that when you're working on a big team in a big company, you need to have ops capabilities. That doesn't necessarily mean you need to have like a team of ops people standing by ready to automate everything for you. It means that you need to have developers with the mentality of, we have to do operations work as well. It means you need to automate everything by using orchestration tools like Chef or Ansible. We need to be able to understand how to properly set up, like developers who can understand how to properly set up an application like Jenkins. There's another CI tool. But with all that said, today I'm going to go against that, what I just said, and I'm going to use cloud-based tools to get this stuff done. So it's totally possible for everybody to understand the building blocks of this and get better and better at understanding how to automate that stuff at a code level. On the harder side of stuff, like CI tools are necessary. CI tools are basically running our code and running tests. And for those of us who are on Macs, the CI tool is probably running on Linux, so the CI tool is always going to find that one bug of capitalization that drives us mad, because after you put something into production, it can't find specific React element or whatever. That happens often. And we need integrations to the code repositories themselves. It's not one centralized server sitting and holding a code repository. We need hooks from that. We need to be able to say when stuff has come in. We should be able to pull that code from a code repository from our CI tool, automate a bunch of other stuff. Once all those tests pass, great. Let's then use our automated operations scripting, our orchestration tools, and deploy the code up to our cluster of servers. That's like continuous deployment at its finest. That is saying, hey, the team is so capable, the team is so responsible, the team is so confident in their own abilities and their own processes and the rigor that's gone into this process that we're going to put code up every single time somebody merges something in and test pass. How awesome is that? That's the environment I want to live in. That's the environment, not live in, but like work in. It's the environment I want to sustain long term, and that's an environment that's always going to be on any team that I'm on. And like I get the luxury of saying that now because I just build my own teams. But I've done that in the past where it's just having to go and get management agreement. What's my time at? Ooh. So let's actually dive in. Can everybody read that? Okay. I have the benefit of, I think, a little bit more shade. So I'm going to start off with the test side of things. As I said, I've written almost all of it, but I'm going to do like this little tiny interlude into test-driven development. But basically what I'm going to do is I'm going to build an application server, which is living here in libindex. That application server, it should work. So it's a big requirement. I do that by, I'm just going to hit the slash route. And that slash route should return a 200 response code. And I'm actually going to make it, I'm going to add for myself a little extra thing. And that application's response body has a message property that is going to return this string hello world. The other couple things that I'm doing, not really that important, but just for the sake of having more tests in here. put that in there. So in this case, every single get route is still going to return a hello world, but on unknown post routes, it's going to return, On unknown post routes, it should return a 404. So those are all pretty standard things. What I'm going to build now, too, more specifically than this, that I'll talk about in a second, I'm just going to build a really, really simple calculator. Put two numbers in, and we can add, multiply, subtract, or divide these numbers. So let's go into some tests. My adder tests. Let's look at this one first, actually. My adder, if I send in 2 and 2, well, the result of that adder should be 4. And the thing is, if you see here, I'm not actually testing my endpoint. I'm testing the code underneath my endpoint. I don't need to test Node's HTTP libraries. They can do that for themselves. I want to test my own specific code, which means that I want to, like in a real world application, I want to test my own utilities. I want to test, I know that my API is going to work in the grand scheme because I tested in the previous file, or I'll have a health watch. But I want to make sure things are up and things are kind of working. I could go into actually wrapping up my endpoints of tests, but in this particular case, I'm choosing not to. Because the thing is, with continuous deployment, you got to be pragmatic about what you test. You don't want to spend half your week writing tests and the other half of your week fixing tests. You want to spend as much time as possible writing code that is functional, and that is important. So here I have, it should return a promise, this adder function. I'm doing that just for the sake of simulating, like this is a bit of a contrived example, but it's an example that's important for simulating like a proxied server. So let's say that my API endpoint is proxying over and wrapping up calls from a completely different API, completely different application. I want that to return a promise. I want that to be thenable, etc. The other thing you might notice is that I'm actually using Async Await, because I'm using Node 8. So it's just more convenience, but it's adding a few more requirements to this. I'm making my application a little bit more contrived, complicated, just so that my test runner is something to actually do, other than just making sure that things can, that I can run like or that I can write a basic JavaScript expression of x plus y. So for all of these, adder, divider, multiplier, whatever, they all should return a promise. And then they should do like the basic mathematical functions. In the case of multiplier, right? I also want to make sure that I've covered the case of what happens if I multiply something by 0, negatives, positives. With divider, I want to make sure I get this cool infinity primitive that JavaScript ships. I actually tested this before this talk. I was like, shit, is it going to break? Or it was infinity. It was good. I've once actually done like a demo thing before another talk I was doing on Fiverr, where I managed to actually run out of memory on my laptop, and it just got super hot, and it just completely died about 5 minutes before the talk. Mercifully, got that back up, started the talk, then got like a few slides into my deck and realized that I didn't have the internet working, which meant that these some Twitter tweets, not Twitter tweets, tweets that I'd put into my deck, they didn't work at all. So they were just completely the dead icon, the dead image icon. So completely. Okay, so back to where I was. The other thing I'm doing here that is behind the scenes is that I'm using Jest as my task runner, or as my test runner. Sorry. So this describe and it. Well, we don't actually pull those in, because Jest is going to be running those at runtime. It's going to be injecting those globals into my particular tests. You don't necessarily have to use Jest. You can use a multitude of other things. People here, I'm sure, have used Karma, Mocha, Tap. Eric Elliott loves Tap, so lots of people moved over to Tap at one point in time. To me, Jest is kind of my single ubiquitous test runner, because it lets me test my React components in a very nice manner when I have React components. And I can use the same stuff that I use for node testing here. The other thing I use, and if anybody was savvy enough to see this, I also use this other library called Supertest. Supertest lets me actually run really quick requests against my app. And now let's dive right into my app. But I'm going to dive right back into this thing for a second. And the thing here is that I'm creating a basic Express app, and I'm exporting that. Apparently, I'm exporting the app.listen as well. But sorry, that actually works. But basically, Supertest lets me run hit this API and run requests against it, and it returns proper HTTP status codes, etc. So let's dive into my actual application. So who here has used Express before? Excellent. I don't have to explain that. That would have been tough. I'm using Express, very simple configuration. Not a whole lot to it, just Express and body parser. This is a JSON API. I'm just logging out certain things. I'll explain why in a bit. We'll come back to this. These are my specific adder, subtractor functions, etc. In here, there's a little bit of opinion added in that I haven't really talked about, but my request.body, basically I'm going to be sending it an array. And that array's got 2 elements, or the array could have like way more elements. I'm just going to pick the first and the second one using destructuring here, array destructuring. And then I'm going to pass it into the particular operations that I need. All of these things are routed based off of my routing table here. And again, I'm using Async Await just because I'm returning a promise. And I want Async Await to actually grab the contents of that promise, the resolve portion. If you don't know Async Await, don't worry. It's not that important for the context of this talk. But it's just something that's like, if you go back and you're looking at this later, and you're like, okay, let me go see that what dumb shit Rohan wrote. It's a good thing for you to like pick up on later. And then finally, I'm just going to send back the result of this in a JSON object that has a result property. So everything here is pretty standard, unless anybody contradicts that. No dissension. Okay. So then I have my actions here, and they're all really simple, right? My adder, subtract, like they all have the same signature, and they actually, use a JavaScript expression for adding, subtracting, multiplying, and dividing. So I have all my sweet code written here. Here is, nobody can read that, I know. Don't worry. I'm going to fix this. So just to prove that this thing works, hold on. All right. Just to prove that this thing works, here's my application running down here. I'm just going to run a quick curl to localhost 3000. Yay, hello world. And down here you see app log. It's just logging out the different things that I'm doing. Let's do to adder. Again, hello world, because I'm just making a get request every time. So let's actually jump into Postman. And in Postman, everybody here kind of knows what I'm doing with Postman. If you don't, just raise your hand, I'll quickly explain. So Postman allows me to make HTTP requests and allows me to do stuff like post bodies and all that without having to Google to figure out how to send a post in curl, which often takes me on strange paths. So Postman is just going to let me do everything, control my headers, etc. So in this case, my headers are I'm looking for application JSON, and I'm just sending an array, 1 and 2. Right? You can see if I send it, I get a result of 3. Awesome, my application's working. Let's subtract these numbers. Great, application is the result is -1. So we can see that we're functionally working. At this point in time, in some teams, it's like, okay, let's run this through QA. And you're going to have a couple different QA people sitting there trying to think of every single permutation under the sun to break this application. But that's not really a good use of anybody's time. We can just automate those tests. And luckily, I've written those tests, and doubly lucky, I have this awesome thing where I can go yarn test, and hey, it runs my tests. Now, my problem here is that I have 2 running applications, but don't worry about that part. So when I look here, I see, oh shit, I have failures on my tests? And the thing is, Tyler could have written this code, sent it up, and I'm sitting there doing some stuff, and I've broken the intent of what his code was, the test that he wrote. And in this particular case, This is Jest output, by the way. This is why I like Jest. It's very pretty. I'm failing on these should return a promise. Wait, these things are not returning promises. So let me change that. Go like this. And I'm just going to make this super, super simple. Right, I'm just going to go promise.resolve. Just going to return a promise. This thing updates down here. It's got nodemon going. Node daemon. And it's still working in that sense. This is my functional test, my smoke test. This time I'm going to kill this because I'm going to still have an issue. Let's run this again. Bam, all but one failed. And this is the one that I just changed. I'm going to go back to the... I'm going to go back to this because I didn't test for that. But again, yarn test, let's run through. Wow, everything passed. 5 test suites passed, 19 tests passed. Took 1.1 seconds, all in all, 1.59 seconds. Not too bad. Now, the important part here is that when I make changes, I want these changes to actually go and hit a different automated, running in the background, far away from us system that is going to tell me that all of these changes pass after I merge my code. And I want to, again, like I want to make sure that it's not passing on my system and failing on somebody else's. Like who's ever heard the line, but it works on my machine. Right? And 9,000 times out of 9,000, I don't know why I was going to 9,000. But it's usually just because there's some stupid lowercase thing instead of an uppercase thing that makes it break on Linux. So we have test runners that are running in a closer approximation of our environment. So, like I said, we're going to use CircleCI in theory. There it is. Okay, sorry, I should quickly say, I've glossed over this part, but my code is all pushed up to GitHub. It's all publicly available. The main point here is, though, when I push code up, I want that code to be pulled in. This is my task manager, or my CI runner. My CI runner currently has failed tests. So, context of this, it's pulling in my code every time I push to GitHub. It's pulling in that code and it's running all my tests against it. And remember, like I just ran it locally and they were all broken. That's why this is currently failing. So let's go inside and take a closer look. This is CircleCI specific, but a lot of a lot of CI tools are very similar. It'll always tell me that I'm missing some sort of config, because I always forget to. But big thing here is that the status. We want to know what was the last commit that actually went in here. Super important part, right? If like 6 different people are pushing code up, we want to know whose code actually broke it. We see here it's big and red, as in like really driving home the point. But we have all the different tasks that we need to do within this. CircleCI itself is using Docker to run each test. It's making like a little Linux environment. I can control that in many ways, but the important part here is, and I'm going to explain why this is happening. There's a circle.yaml that's putting in some envvars. In this case, yarn version and path. It's setting my Node.js version to 8. In this case, it's restoring a cache because it's got a bunch of things cached already, dependencies, etc., and it just speeds up the full application suite. In my particular case, I'm using yarn, so I want to actually use my yarn lock file. I pull yarn in, I do my yarn install. You can see all my wonderful node output. And then ultimately, it runs through the test. And again here, we can see, should return a promise, should return a promise, should return a promise. I just got that passing though. So lastly, it publishes a bunch of metadata and stuff, so we can, if we want test coverage, we can do a bunch of different things. So let's quickly add this code in. This little guy right here is telling me I have stuff that I need to stage, so let's go check git status. Okay, I'm going to quickly do a git diff just to figure out exactly what I changed. Which looks good. Did some changes there because I had a try catch, I had an uncaught promise. And I added some other interesting tests in there. So I'm just going to git commit. By the way, this is not a workshop on good commit messages. Wow, that didn't work. There we go. That was a new bug. I'm going to push this. So when I push this, these changes are going to come over here. Bam, fix some bugs. And we see the diff of what we fixed. Ignore the rest of the diff. But what's happening here behind the scenes is that CircleCI is actively polling Git to see if there's new changes to be run. In our case, I didn't have to do anything, and all of a sudden it started a new test run. And let's go peek on it. It's currently restoring the cache. It's going to go do everything. It's going to go run to the test again. Generally speaking, I'm pretty confident in this. It worked on my system. It should work on another system. I haven't actually done a little contrived thing. I should have, in hindsight. But it's going to run to this. I'm going to get a nice green passing system. Green light that's telling GitHub that everything's good, et cetera, et cetera. So right now, yarn installing. And this is not a very big application. Sometimes these test runs can get pretty hairy, pretty big. But it's not overly complicated in the big scheme of things because it's not preventing you from doing work. That's the point. That's why we have test runners that are sitting on external services, external servers, somewhere far away from your local machine. So you can actually just run this stuff. Great, we're green again. It's all good. So oftentimes, if you go start at a company, you might see just a whole bunch of red tests. And your goal is to get to green. Sometimes those companies just don't bother getting to green and just keep going on red. I feel like if I look at my old application here. Oh yeah, I fixed it. But the point here is to get to green tests. This is continuous integration. Right? So now if Tyler goes back, he can be reasonably confident that I didn't screw up what his awesome work was because I've gone and fixed it. So that's the basics to continuous integration. But continuous integration with a team is a little bit different. So let's branch. Check out. Right, I'm going to do a new branch. And in my new branch, let me make a really, really material change. Super material change. Right, so we gotta document the code. Let's check out this. All right. So I'm going to go git commit. Making some important changes. Okay, no exclamation mark bug. I'm going to push this. And I mean, generally speaking, I'm not going to be pushing to master. Actually, realistically speaking, I should never be pushing to master. I should always have a different branch. So let's come over here. Great, let's create this pull request so my team can go and see. And if you see right here, whoa, CircleCI is actually going to run these tests because when I do my initial integration of CircleCI and GitHub, which is 2 clicks, it automatically adds it in there. So we can see on every single pull request what the status is. We can actually set the repository to prevent or to not allow people to merge code in that doesn't have passing tests, that fails on. You can add style stuff to CircleCI and stuff. Somebody's adding semicolons into your pristine code base. Get that out of there. This literally happened to me 2 weeks ago. I literally turned on protection of merging because one of my teammates decided that he didn't want to install Prettier on his system. So we didn't merge for a couple days. But what's going to actually happen here behind the scenes is running my tests. And hey, let's go check it out. Look at this, new branch, WebSockets. Amazing. And this thing is going to go run through this entire system. It's finished this. It seems like my test being green here in its 4 seconds of glory has completely passed. Great. Let's go back to GitHub. All checks have passed. Right now, let's merge. I'm going to squash and merge. Let's merge. Let's delete this branch because we don't want any of those things lying around. Right. All of a sudden, we have new code. And what's going to happen? We're going to have master run again. This is the integration testing. Right? Previously, it was just making sure that I had met my base level to merge that code. Now it's making sure that if Tyler's sitting there currently not paying attention to this presentation and merging code, that our stuff isn't conflicting. That's the important part. Sorry.
Oh, I said I was busted.
Oh, yeah. So this is great. Now we've gotten to continuous integration. Really, if we're very happy with our code and all this stuff is passing, we can even go the step of saying, hey, ops team, hey, release manager, like we're just going to keep pushing this stuff out. We're not going to have release cycles. We're just going to push code up when we want it to. And that's where a lot of teams kind of end up. And it's like a very nirvana place. We've done the requisite level of work. Right now, my master test is probably going to pass. I'm a developer with access. I can push my code up to create a new Docker container. I can push that code up to my staging. Right? And we can wait for other stuff, but the main thing is, I as a developer now have control over the process. I can do that. But still, like, it's really nice and all to be able to push stuff up, but I don't want to have the problems associated with it. Like, I was about to show you some all the different deployment steps I need to have for my current application, where it's like 7 different layers of Docker and it takes like 45 minutes. And every day I'm just complaining about how I need to find the time to actually automate that stuff. Because the point is, you don't want to be sitting there typing out all the different directions, even copying and pasting. I mean, who heard about the big GitLab database debacle? Right? It took down some people's systems for a few hours because it was manual processes, and there weren't enough things done to mitigate these sort of issues. Mitigate the sort of issues when somebody types in the wrong command. Did anybody read that Reddit thing lately about some guy who on his first day of work managed to reformat production databases? Now, had they had continuous integration or some rudimentary checks and balances. So at this point in time, we have master. It's all green. It's all good. I'm going to use Heroku to do my deployment tool. So this is a very fresh Heroku installation. Not installation, but a fresh application. All I've done is just found a name for it. I've literally done nothing else. So if we look at my settings over here, it's got nothing. It doesn't even have a build pack. So what I have done, though, previously is I have my Heroku hooked up to my GitHub. And my GitHub is hooked up to CircleCI. So let's put some stuff together. What I'm going to do is, once I find it, go over to the deploy tab. I'm going to go. My deployment method is not going to be through Heroku CLI. So who here has used Heroku before, I should say? All right, for those who haven't, you can do deployments straight from your command line. I would show it off, but like right now, for the sake of time, I'm not going to. I'm instead going to go right here to connect to GitHub. What did I call my repository? CI talk June 26th. So I'm going to search for it. Bam, let's connect that. So here, I'm going to do 2 things. One, I'm going to say I always want to deploy off master. I don't want to deploy off random feature branches. That can be done, but I'm not going to go into that. But I'm going to wait for CI to pass before deploying. I'm going to enable automatic deploys. So for this particular portion, I'm going to do a manual deploy right now. And I'm going to show you what happens when we have more material code. This manual deploy is what I need quickly to just set up my Heroku environment so that it knows that I'm using Node, etc. Meanwhile here, I'm just going to go Heroku logs to see what's going on. May not have set up my... All right, not largely important. Let's go back to master. I'm going to pull. So let's, again, make another really material change while in the background Heroku's pushing up something. So I really like spaces between these 2 lines. So I'm going to make sure that happens. And lastly, I'm going to fix a bug that I have. And I'm actually going to export app, not server. Because server is actually the started at 3000. App is going to allow me to run both things at once. Again, we're doing good practices. What should this branch be called? Tyler, pay attention. And I'm going to quickly diff that. Oh, look, awesome spacing. Fix that one bug. Bug, theoretically. fix some bugs. Right, great. Let's push that. Let's go over to GitHub. Bam, GitHub sees that. Let's do a pull request. And now, Tyler, pay attention, is running on CI in theory. Bam. So at this point in time, this is still continuous integration. But I've set up something else. I've set up a pipeline that's saying, let's do an automatic deploy when my CI test passes for the master branch. So after we merge this, and I'm actually just going to do something terrible. I'm going to merge this before this test even finishes, just because for the sake of time, I'm going to kill this branch. I'm just going to stop this test. So never actually do that. Only when you're doing a talk on it. So back here, master, theoretically fix some bugs, etc. When I come over here, this test is running. And if I come over here, so my previous thing was deployed, but now what's going to happen is that once this this code that is now merged into master passes CI, and still I can tell by the favicon it's still blue. Once it passes, it's going to automatically, using GitHub hooks, see that the CI is passed, and then actually do a code deploy. Now, in theory, probably not in practice, I could look at my logs. Yes, my logs are back. Now, the one problem I just suddenly remembered I had is that I didn't actually write a start task. So it doesn't matter though. For the purpose of this, it doesn't actually matter that this application is working. But we're going to see in these logs up here, eventually, it's going to actually shut down the application. Unfortunately for me, it's already shut down. Again, human error right here. This is why we need to automate stuff. But it's going to actually start pulling in a proper build once this thing is done. Estimated 120. Oh, okay, there we go. So, test is passed. Now Heroku's doing some interesting stuff behind the scenes. If we look at this overview, we see deploy happen a while back. If I look here, nothing's really happening. And I don't know the timings of this specifically because it's actually polling. But it's going to go poll. It's going to figure out that the CI tests have passed, and it's going to go create a new deployment. And it does that by understanding what the previous Git commit was, compare that to what's happening in the current build that's sitting on Heroku servers, and bam, here we go. It's now deploying completely without me having to do anything except for writing my awesome commit messages and like merging my pull requests, which theoretically I have like a massive team of. Again, it crashes because I don't have a start script. But yeah, screw it. You know what? Let's put a start script in. So I'm using the debug, library. That's why that's there, if anybody's wondering what that means. Highly implore you to go play with it, check it out. It's really good. And adding these debugs into your environment variables will kick up your logging a notch. For the purposes of this, I'm just going to keep going past. So git status. I need to go back to my proper branch. I got a stash. So git commit -am, adding in a start task. I could have done this with proc files, but I'm not going to worry. So again, in theory now, while I'm going to sit here and try to fill up 5 minutes, my CI tool is running. It's running my tests, etc. And this is going to get this log up here, which I'm going to clear. You're going to see it working again. It's going to have something being pushed up. That CI test takes 1 minute 28 seconds to run, I believe. And we'll actually see an application that theoretically will start. Now, as I'm saying this, I realize it's not actually going to start because I actually haven't made my application Heroku ready. So instead, I'm just going to quickly move past it. Just take my word on it that once your application is Heroku ready and it's got the proper ports and all that environment variables, it'll all come together.
You have a PR, by the way.
I have a PR?
Yeah.
Oh, God. Oh. Tyler comes from the Rohan school of writing commit messages. Ooh, this test itself is failing just in definition. Also, man, that's some terrible formatting. So anyway, in theory, I would have some sort of ESLint tool that would have failed Tyler's attempt at a pull request. But yeah, so that in a nutshell is continuous integration moving into continuous deployment. So this is again going to fail, isn't it? So it'll pull. I'm going to talk quickly. So the main things here are it's actually something that you can reasonably do in 45 minutes if you don't forget to put proper Heroku environment variables in. With a public repository, people can heckle you from the back of the room by putting in pull requests. And in theory, your test may pass. I don't even know. I mean, expect true to be true is a pretty simple test. We can factor that out to just true. Okay, there we go. It fails again. But yeah, that's basically all I really wanted to cover. Let's go back into this because I have this awesome quote that was going to tie my entire presentation together. Ken Beck is a creator of extreme programming, which is extreme. If anybody's ever worked at Pivotal, or know people who work at Pivotal, they do some extreme stuff. But the point of all of this is just to ship. Shipping code is ultimately the most important part, and that's what we do as developers. We sit there and we ship code. Thank you. Look at this lovely stock picture.